Irma quickly proved it was a force to be reckoned with, becoming one of the strongest hurricanes we've ever recorded in the Atlantic Ocean. Now, this frightening storm was led toward Florida by a strong area of high pressure in the Atlantic. It's called the Bermuda High. Now, hurricanes glide west along the southern edge of this high pressure zone, and depending on its strength, a storm can take a more northerly or southerly track. Now, forecasts on the Friday before Irma's landfall showed the southeast coast of Florida in the National Hurricane Center cone, driving Irma up the state's spine. This would have resulted in disastrous storm surge for Miami and its beaches. However, there was also a mass of dry air and low pressure that had to be taken into consideration. Meteorologists call this a trough, and it kept Irma from trekking farther west into the Gulf of Mexico. Now, we knew this trough would eventually weaken the Bermuda High and then bring Irma up towards the north. But the strength and the speed of the trough is extremely tricky to predict. So the big question was, when would Irma turn north? Well, the trough moved very slow, so forecasts by Saturday started taking Irma farther west up the Gulf Coast of Florida, where over 4 million people live, with a possible worst-case scenario from the Keys all the way up to the Florida Panhandle. And this is how everything played out right here. By Sunday morning, the trough's dry air began getting sucked into Irma's circulation, weakening the storm and steering it farther up towards the north. So as Irma absorbed this trough, the hurricane wobbled, passing far enough west of Orlando, but not far enough to hit Tampa or get back into the Gulf of Mexico, where it could re-strengthen. And believe it or not, that is just a brief overview of how many variables there are when forecasting these massive storms. Not only that, of course, every storm is different. So let's take our most recent Nate and Irma, plus let's add Matthew in for some comparison. We just went over what happened with Irma, of course, but Nate, this storm was tugged toward the north, away from Florida, thanks to strong high pressure in the Atlantic, and no influence from a trough. Now, Matthew, on the other hand, was pulled along that southern edge of the Bermuda High, similar to Irma. The difference was we had a strong cold front approach, or called a trough, and the high pressure didn't budge either. Therefore, Matthew slid between these two air masses, barely clipping Cape Canaveral and eventually making landfall in South Carolina. Now, in the end, this cold front won, making Matthew recurve back out to sea. Bottom line, timing is everything. And if you don't have these perfectly timed cold fronts or strong enough of a high pressure system, for example, then sure, we're at risk. So trust your First Coast News storm experts, because we are here to break down all of this complicated meteorology and get you through the rest of this hurricane season and hurricane seasons to come. In the Weather Center, I'm meteorologist Lauren Rautenkranz.